in our review of chi-square tests. A survey was conducted 2 years ago asking college students their top motivations for using a credit card. The percentages are shown in the table to the right. Also shown in the table is the observed frequency for these motivations from a current random sample of college students who use a credit card. And so here, using a significance level of alpha 0.1, perform a chi-square test to determine if the probability distribution for the motivations for using a credit card change between the two surveys. So here, we're going to look at the hypotheses. First of all, the null hypothesis would be that the new observed values fit with the distribution of owed. So if we look at this, the distribution of motivations is 29%, 24%, 21%, 8%, and 18% as it was in the owed survey. The null hypothesis would be contrary to that, right? That the motivations differs, right? The distribution for this motivation differs from the claimed or the expected distribution of owed. So now we need to run a chi-square test to see if there's a good fit. So I'm going to first grab the data, put it into StatCrunch. So it shows up here in this table. So we're going to do a chi-square test, goodness of fit. We're going to choose stat, goodness of fit, chi-square. Then we're going to select the column of the observed values. The observed values are the count in the new survey. All right, the expected is going to be from the owed survey percentages. And so we're going to compute or run the test. So from this test, we get a chi-square statistic and rounded to 2 decimal places. That's 12.56. And we get a p-value that's quite small at 0.014. And that significance level, remember, was 0.1. So our p-value is less than the significance level. So the p-value is the probability of observing a test statistic at least as great or greater than the test statistic that we actually observed, assuming that the null hypothesis were true, right? That the distribution of the variable is the same as the given distribution. So our conclusion would be we would reject the null hypothesis. So at this 10% significance level, there is enough evidence to conclude that the distribution of motivations actually is what? Different. It differs from the claimed distribution. So there we run a chi-square test, right? A goodness of fit test to see if what we observed fits with the distribution that we expect. I hope this helps.